So with vision, there are two pathways. That's what we're going to map out here. That way we can really see it. And I'll do it in different colors. Okay. So this first pathway, the one that involves the corollary discharge, we will do this in red, I guess. I had to make a decision there. Remember, with these two different pathways, the superior colliculus here receives 10 to 15% of the fibers. So we're going to the retina, to the superior colliculus here, okay? The superior colliculus is a machine-like structure. This thing is very fascinating. So like with things like barn owls, those types of species, it's called optic tectum. There's a lot of good research about the optic tectum in barn owls. I mean, they have those funky head movements, and their vision, they can just pick up targets very fast and accurate. It's because they're optic tectum. So about 10 to 15% of the projections coming in from the retina will go to the superior colliculus. Retina to the superior colliculus. The superior colliculus will kind of we'll talk amongst its little nuclei. Okay, this is the raw information coming in. This is what I know about that raw information coming in. So it will have some crosstalk here within it. And also drew out, if we're looking at it from the back side here, remember this is the midline right here. So ipsilateral, each hemisphere, and then contralateral or both hemispheres. Okay, so I should say ipsilateral this way, contralateral this way. Now, you know, probably like the vision, it kind of does this number right here. It kind of crosses hemispheres. We're going to bypass that. That's not important for the corollary discharge. So the lateral geniculate is here, and the superior colliculus is here. Superior colliculus is above the inferior colliculus. So vision, 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 vision. Auditory down here, and auditory in the medial. So the superior colliculus will talk within itself. And then there's a nuclei here in the thalamus, right here. Medial dorsal nuclei, or subdivision of the thalamus. Now, this is a relay station, but it's not for sensation. It's for prediction relay, essentially. So the superior colliculus will send some information. It will talk up to the medial dorsal thalamus, MD. So the next spot is superior colliculus to the MD. Within the superior colliculus, though, before it speaks up to the MD, it's formulating a map. This corollary discharge is putting together these instructions, and then it sends it up to the thalamus. Remember, the thalamus is workhorse. It's a sensory relay station. Plus, it's receiving a bunch of information from the cortex. The medial dorsal thalamus will speak up, way up here. It's a distal connection to the frontal eye fields. The frontal eye fields are roughly right here. So we have, we'll just call it right here, FEF. Frontal eye fields. The corollary discharge is going with it, CD. The frontal eye fields will continue to speak back and forth to the medial dorsal thalamus. It's kind of a feedback loop. It's giving it updates. Okay, this is what's happening. This is how I need to adjust. Remember, because this is a relay station for predictions. It's just helping the frontal eye fields receive information about, okay, what's next? The frontal eye fields will speak over to the parietal lobe. There's a subdivision called the lateral parietal and the posterior parietal. Lateral, intraparietal, and the posterior parietal. It's kind of this garbage nomenclature. You don't need to know this. But what you do need to know is the parietal lobe is kind of piecing together the information from the corollary discharge and the information from the frontal eye fields to help sensory integration. Okay, so we have MD to the frontal eye fields to the parietal. The parietal will speak back down to the thalamus.